Hello guys, in this video we will see how we can implement a simple RNN model to learn a text. Okay, so I'll try to train a model which can learn the poem Jack and Jill. So I'll just make use of the first para of that poem and let's try to train our RNN model to learn that. So when I say learn that, if I give first word or second word or first few words, it should predict the correct output after those two words or the first word. Okay, so let's see if we will be able to do that. So in order to do that, I'll be trying out two model architectures. So basically it will be like this. So I'll try one word in, one word out model and two word in, one word out model. Okay. So it will be like this. So when I say one word in, one word out, it's like this. So I'll have my RNN block here. I'll have one time step. I'll have the output at that particular time step. So this is my one word in, one word out model. So in my two words in, one word out model, two word in, one word out. So how this would look like? So I'll have two time step inputs before I actually predict my output. Okay. So x1, x2, and then I'll have my output. Okay. So I'll have my a1, a2. So this is how the model architecture looks like. Okay, now let us start our implementation. Okay, so hope you guys clear on what we are trying to implement it, right? So let me open up a notebook here and let me import the required libraries. Okay, so we will be implementing it using Keras as a deep learning library. Okay, I'm not implementing it from scratch. So if you guys want me to implement it from scratch, please let me know. I will do that as well. Okay. So let me import Keras. From Keras.models import, I need to import sequential. Then I need to import from Keras.layers.recurrent import simple RNN. Okay. Then I would be needing numpy array, numpy. So I'll be importing it as np. And finally, I need matplotlib to plot the accuracy and loss curves, right? So I'll import that. Import matplotlib.pyplot as plt. So these are my. So it says okay. So there is a spelling mistake here. Now it should do okay. Now I have imported my libraries. So now what I'll do, I will have my data. So it will be Jack and Jill went up the hill to fetch a pail of water. Jack fell down and broke his crown, and Jill came from tumbling after. Oh, sorry. So it should be tumbling. Jill came tumbling after. So I think this is right. Jack and Jill. Okay. So this is my data. This is the first part of the poem which I want my RNN to learn. Okay. So this is how the data looks like. So always the first step is to tokenize and have the vocabulary ready, right? So how we will do that? We will make use of something called as tokenizer, which is available in Keras. Keras.preprocessing.text. Okay, so it's text dot tokenizer. So I initialize this tokenizer. So it should be preprocess keras.preprocessing.text dot tokenizer. Okay, so there's a spelling mistake here, right? So tokenizer. Okay, I have initialized my tokenizer. Now what I'll do, I will ask this tokenizer to learn the tokens on this particular text that we have here. So in order to do that, what I have to do, I have to call fit on texts and then pass in this data. Now I have to pass in this data as a list. Why? Because it expects the input in the form of a list. So how do I know that? If you just press shift tab here, you will see fit on text. So updates the internal vocabulary based on a list of text, right? So argument is text. It can be a list of strings also, but it should be a list. So that's why I'm closing it in a pair of square brackets. Now that I asked it to learn the tokens, what I need to do, I need to extract the tokens and store it in some variable, and let me call that variable as encoded, and then tokenizer dot, I'll convert this text to sequences. And what is the text that I want to convert to sequences? That's data, right? So now if I check my encoded, okay, so it has done a fair job. So it has returned the text into some set of numbers based on the vocabulary that it has learned during this particular step. Okay, now this has returned as a two-dimensional array, right? So I need to have it in 1D so that I will not mess up with my inputs and outputs later in later part of my code. Okay, so I have now this as 1D. So what I did, I just substituted it with a value of 0 so that I'll have the first item from that particular two-dimensional array extracted out. So now I have this encoded text in a one-dimensional array. So now, what are these numbers? I need to know which number represents which word, right? So that it makes some sense. I need to verify. I cannot blindly trust this tokenizer, right? At the initial step. So if we are using it for the first time, I cannot blindly trust it. I have to double check if it's working properly. So how do we do that? How do we check that? So there is something called as tokenizer dot, there is something called as word index. So this will give me the dictionary where it will have the mapping from word to numbers. So now if you check Jack and looks fine, Jack and Jill, and if you want to verify it, you can have it verified. Okay, so this is how it has constructed the vocabulary and assigned the numbers to each words. Okay, so now we will start developing our model. So first is one word in, one word out architecture. So one word in, one word out. So for this, I need to prepare the sequences, right? So when I say one word in, one word out with respect to this particular data, when I input Jack, I want the output to be and. When I input and, I want the output to be Jill. If I input Jill, I want the output to be went. It goes on and on till I encounter my last token after, right? So if I input my token tumbling, I should get my output after. So this is how I need to prepare my sequences, one in, one out. So I have to prepare a pair of words, input word, output word, right? I have to call it as, I will call it as a sequence, right? So let's prepare that first. So for that, I will create a variable called as sequences, and it will be a list. Okay. Then what I'll do, I will, for I in range of 1 to length of encoded. So this is my encoded text, right? So I'll run through this in order to prepare the sequences. And remember one thing, I'm not preparing the sequences on the text. I'm preparing the sequences on the encoded numbers. Okay. Because in the end, I need to feed those encoded numbers into my model to learn it, right? So that's why I'm using encoded. And the reason why I'm using one here, you will see it in a while. Okay. So what I'll say, sequence is equal to encoded of I minus 1 to I plus 1. Okay. So you see what I'll do here. So this is my encoded, right? So I am starting from 1. Okay. So initially I will be here. I minus 1 is 0. It will be 2. I plus 1 will be 1 plus 1, 2. So that is excluding 2, right? So 0 and 1. So this will be my first set of numbers. I'll get 2, 1 in my variable sequence. So then what I'll do, I will append this sequence into sequences list. Sequences dot append sequence. So now if I execute it, then if I check my sequences, you will have it in pairs 2, 1, 1, 3, 3, 4, 4, 5, like this up to 20, 21st word. So what's the 20, 21st word? Tumbling is the 20th word, 21st word is after. So you get an idea, right? So if I input tumbling, I should get an output after. If I input crown, right, it should, what's the output? After crown, what it is? And. So output should be and. So that's how the sequences are generated. Okay. Now let us check how many sequences we have got here. So these will be our input output pairs. So we have 24 pairs of our sequences. Okay. Now what I'll do, I'll separate out x and y's. So how I can do that? I'll so this is a list, right? So in order to quickly separate out x and y, I need to convert it into array. So what I'll do, sequences is equal to np dot array of sequences. Okay. Then what I'll say, x comma y is equal to sequences all rows of 0th column. Okay. This will be my x, and then sequences of all rows of my first column. These will be my y. So if I check my x, so all these things 2, 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these will be my x, which are inputs. And if I check my y here, right? So these are my outputs. Okay. Now what I have to do, I have to encode these outputs in a one hot encoded array. So that's our second step. First step is always to have a corpus, create a vocabulary, encode it into numbers. Then our second step is to create one hot encodings of our output. So how we can do that? We can do that using Keras utility. Keras dot utils dot, there is something called as toCategorical, and it will accept y as input. Okay. So now we have total 21 words, right? In our vocabulary, we have total 21 words. You have seen it here. So word index. So our vocabulary size is 21. So I am expecting this toCategorical to produce me one hot encodings for each of these outputs as a vector of 21 size. Okay. So let's see if that's the case. So if I check y now, so it has given me this output. In order to check the shape, it will be 24 cross something, right? So 20, okay, see, I am expecting it to have 21 length, but it is giving me 22. Why? Because this toCategorical reserves the 0th index and it will not be assigned to any of the numbers. So you can, I think they have the explanation here. Let me see if I can get to that. None. 0 to, okay. No, there is no explanation in this. So if you just Google it, you will get that explanation. Okay. So it actually starts assigning the integers from 0 to number of classes. So it will total count 21 as 22, 0 to 21, 22. And the 0th index will not be assigned to any word. So that's the reserved word. That's the reserved index for any words. It will not be assigned. Okay. So now we have to tackle this while we are dealing with our model design. Okay. So now I need something called as vocab size. So I'll call it as vocab size, and it will be length of tokenizer dot word index. So I'll get my vocab size. I think it has something called as tokenizer dot word counts. Okay, so no. So each word, how many times it's repeating, that's giving it. So this is how you take the vocab size using the tokenizer. Okay. So we have seen y, right? We have to deal with this 22, right? For the strange reasons, how this toCategorical outputs is, right? So now we want our x to be a 3-dimensional array so that we can input to our RNN model. So let's reshape it, right? So how we can reshape this to a 3-dimensional array? It's simple. X is equal to x dot reshape. So x dot shape of 0, so that's 24, and each is of 1 dimension. So I will convert it. Now if I check my x, you can see it is a 3-dimensional array, and x dot shape, it's 24 comma 1 comma 1. Okay, we always need the inputs to our RNN models or any deep learning models to be for Keras library. In Keras library, if you are dealing with text, we need it to be of 3-dimensional spaces. Okay. So that's why I have converted my x into 3-dimensional space. Now let me create a model. So this is the main part, creating a simple RNN model. And remember, this is of type one word in, one word out, right? So we are dealing with one word in, one word out. So let's create a model. So for this, let me initialize the model to be of type sequential. Okay. So I have initialized the model sequential. Then I will go on adding the layers to it. Model dot add. So what I'll add my simple RNN, right? So this is the architecture. So input RNN block, right? So I'll have my RNN block here. Keras dot layers dot So I think I have imported simple RNN. So I'll just make use of simple RNN directly. So this will take the input. So I'll say, let's say 32, comma, input shape. So in what shape the input it should expect, so that we need to pass to it. So it will be none comma 1 comma 1. So why none? I'm not representing it. By default it will take none. It will be the number of inputs. Okay. So that will be reserved by default. You will see it in the model summary. Okay. So input shape is 1 comma 1. And then what I'll say, I will say return sequences, and I'll set it to false. Okay, I do not want it to return output for each input at each time step. I do not want it. I want one input, one output. That's it. Okay, I do not want at each time step to produce it. We are by default have prepared the sequences in that fashion, one input, one output, right? So I do not want this. So I'll just set it to false. Then I'll add a dense layer, model dot add. So it will be keras dot layers dot dense. Okay. So dense will be a fully connected layer. You can take that. So how many neurons? We can treat this as a output layer. We can treat this as our output layer. Okay. So keras.layers.dense. So we have the total output as vocab size, that is 21, right? But our y is of shape 24 plus 22. So what we will do? We will have vocab size plus 1 as our number of neurons in the output size, and I need to pass the activation, and it will be softmax activation function. Okay. So now I have added my layers to the sequential model. Now if I check my model summary, so this is how it looks. So I have a RNN block and then a dense block. So how this model looks like? So it's like this. So I have my input, I have my RNN. So let me draw it in a horizontal fashion so that it will be easy to understand the weights total involved. Okay. So I have my input. This is my RNN block, and I have my dense layer here. So this is my dense layer. This is my RNN block, and this is my predictions from this dense layer. Okay. So how many units I have in this? I have 32 units in this. So I'll have, that's 32, right? I have given the dimensionality as 32. Yes. So that's 32. So in the hidden layer of RNN, I'll have 32 units, 32 neurons. You can think of it as. Okay. So what will be the weights associated with this particular setup? So it will be WX, right? So it will be of shape 32 cross 1. So X is just 1, right? We have just one feature. Then this has 32 by 32, which deals with the feedback loop. Okay. And it will have 32 biases, right? And then from here to here, so dense layer has 22, right? So it's 22 by 32, and then it has 22 biases. So total 32 plus this 32 biases plus 32 into 32, right? Plus 22 into 32, this parameters plus 22 biases. So if you add all this, you would be getting the total params 1814. Okay. Just for RNN, it will be 1088. So let's just calculate it if we have computed it correctly or not. We'll see that. So it's 64. And how much is 32 cross 32? So let's just quickly check that. So 32 cross 32, it's 1024. So 1024. So it will be total 1088, correct? If you add 1024 and 1064, it is 1088 weights total RNN block has. So you can see that here 1088, and this 726 is nothing but the multiplication of this thing, 22 into 32 plus 22. So let's see that 22 into 32 plus 22, 726, correct? So that's adding up with the total number of params that the model is displaying in the model summary. So total trainable parameters, so it has to learn 1814 parameters. Okay. Now let us compile this model. So when I say compile, we have to pass in what's the loss that we are going to use and what optimizer to use and what metrics it should track. Okay. So let's do that. Model dot compile. I'll say loss is equal to, I'll use categorical cross entropy. Okay. So it should be categorical cross entropy. I had to type it. It should have some short form. I don't know if it has, but let's give the complete name. Okay, this is how it works. Then optimizer, I'll use Adam optimizer. I think I haven't talked about any of the optimizers except gradient design in my videos. Okay, we'll talk that in my upcoming videos. No worries. Adam, and then metrics to monitor its accuracy. So let's monitor the accuracy of the model. Now that I have compiled my model is ready to be trained. So what I'll say, model dot fit. So this method is used to train the model. Y, x comma y, okay, and then let me say epochs. So let me just try to train it for 100 epochs. I'll set the verbose to 2 so that I'll know how it is performing. So I will store the output of this in a variable called as history. So you'll get to know I am storing this in a while. Okay. So let me just try if it works. I haven't messed up with the, okay, I haven't messed up with the shape or anything. So you see it has trained for 100 epochs, and do you see any improvement in the accuracy? Yes. Also there is a reduction in the loss, but the accuracy is not up to the mark, right? So what we'll do, we will increase the epochs. Let's increase it to 500 and see. Okay, so I can see the accuracy is getting improved. No, I don't see improvement in the accuracy, but the loss is getting reduced. Okay, at some point the accuracy is also getting increased. So towards the end, okay, accuracy is around 41%. So let's do one thing. Let's increase it to 1000 epochs. Let me ask my RNN to run through the data 1000 times and then update the weights. Okay, so let me do that. It takes a while. So this will be quick if you have GPU. Okay, so let me bring this up here. So this is the GPU utilization. So this is a simple GPU. It's GTX 1650. So now you can see its utilization. It's almost done, right? It's 40% occupied. So once the training is done, this GPU will be released. So okay, so training is complete. Okay, so the accuracy is okay, 62.5%, but it's not acceptable because the data is fairly small, right? It should actually do a fair job. So what we can do, let's try to increase the epochs and see. Otherwise, we will increase the model complexity. Okay, so let me increase it to 2000. So as long as the accuracy is improving with increasing epochs, let's not create a more complex model. Okay, so let's see that. So here I have done one mistake. So every time I'm just increasing the epochs and then running it, so the initial loss would be the last loss during the previous training. So that's what you are seeing here, right? So it's not the right way. So what I can do, I can reinitialize the model every time I want to retrain it. Okay, so but in the end, eventually you should see the end loss that you are seeing it here, right? So let me just, okay, so even with 2000 epochs, I'm not able to increase the accuracy to that extent, and also loss is okay, loss is getting reduced. Let's give it a last try with 3000 epochs. Okay, so let's see how it gets trained. If the accuracy is still a problem, then add we will add bit complexity to the existing model. Okay, so we will see that. Again, I have forgot to initialize the model. Okay, so in my next iteration, let's see if I can do that. Okay, so accuracy is you see here accuracy, okay, it's getting fluctuated, 83. Okay, so it's almost constant, it's not learning further. Can I say that? No, I cannot say that because loss is getting reduced, right? Okay, so the model is learning something. So let's say we have nearly 90% accuracy, 87.5. Okay, so let's see how the model performs on the outputs. So this has completed the training, but let me reinitialize the model and train it again. So I'll run this, I'll compile, and then I'll train it again. So this is the last try for training the model one word in, one word out category, one word in, one word out architecture. Okay. So did I import matplotlib? Yes, I have imported it. So let's see. Once it completes the training, so let's see. So if you have the GPU, it will be very quick. And if you have the upgraded GPUs with you, it will be much quicker than what you think. So in a blink of eye, it would get trained because we have so less data, right? So how many epochs it's done? So I could have imported TQDM and showed you the fancy progress bar. So let's keep that aside. We can learn that anytime. It's not a big of a deal. Okay. So, okay, I can see. So the model accuracy is not up to the mark. So let me try to increase the model complexity. Okay, so what I'll do, I'll add another layer of RNN or maybe a dense. So let me first try to add a dense layer, redo, and let me try it with double the vocab size first, and then let me add another dense layer. This will be my output layer. Activation will be softmax. Okay, so let's try this. So it will increase the parameters by a bit. Okay, so it should not affect much on the runtime. So let's see if it helps. Okay, it's gonna consume a lot of GPU again. Okay, so since we have increased a dense layer, this is how the model looks like. So now what I did, I have my RNN block, I have my input, this is my dense layer, its of size vocab size into 2, so 21 into 2, 42 neurons in this dense layer, and then I have 22 neurons in my output layer. This is another dense layer, so it's a fully connected layer, right? So all the neurons will be interconnected to each other. So this is the extra parameter, 22 into 42 plus 22 bias, and this will have 42 bias here associated. Okay, so that's why you see a considerable increase in the number of parameters that it has to learn. So let's see if it has completed. Okay, it has completed training. Okay, it's not increasing. So let me do one thing. Instead of adding a dense layer, let me try to add a RNN itself, another RNN layer. Okay, so what I'll do, I'll copy this. So you can think this as a stacked simple RNN layer. So in this case, I need to set the return sequence to true so that I can feed it to the next layer of my RNN, right? And in the second RNN layer, I can set it to false. Now let me get rid of this. I'll just comment this out. Let me not delete it. And let me initialize the model again. So I'm doing this even if the video is getting a bit long, because I want you to understand how we can play with the model architecture and how it affects the model training and how it's affect the loss and accuracy in the end. Okay, so let's see if this helps us. If not, I'll stop at this particular step, and then we will see how the model is predicting, how the model is performing with this particular setup. Okay, we'll see how much loss and how much accuracy we end up having. So I don't see a particular increase. So we still have a long way to go. Okay, it's 79, 83. Okay, I see some improvement now. Earlier, if you remember, it was around 75, 79%. Now I can see it up to 83%, which is still not good considering the data that we have. It's very less. So it should not face that much trouble in learning it. I think the accuracy got played out here, but the loss is still reducing. Let's see if we see another jump in the accuracy by another percent or not. So no, I don't think the accuracy is increased. No. Okay, so we'll see how the model is performing with this particular setup here. Okay. So now that I have this, let me plot how accuracy is increased and how loss is decreased with the epochs. Okay. So what I'll do, plt.plot. So I have stored the model.fit return into a variable called as history, right? So I can make use of that history of, I can say, loss. So if you see, the loss is reduced at every epoch and it's still getting reduced. It's not, I cannot say it is flat, it's still getting reduced, but I'm not seeing improvement in the accuracy, right? So it has remained constant for almost 1000 epochs, I believe, right? So let's see that. So what I can do, I can plot this. Instead of loss, I can say accuracy. So okay, see, from around 1500 epoch, the accuracy has not increased, it stayed constant. So why this is the case? So it's an interesting topic to discuss when we measure accuracy and when we monitor the loss. Okay, I'll cover it in my another video, but let's get started with testing out this model. Okay, so let me just create a subheading here and call it as testing out the model. So what I'll say, I'll have my input text, I'll call it as in text. So let's see Jack. Okay, and I'll say encoded is equal to tokenizer. So again, a spelling mistake, tokenizer dot text to sequences. I need to convert this in text into the same number as I did during my training, right? So that's what it is. So in text and encoded, it will return me a 2 dimension space array. So I'll want it in a single dimension. So I'll have this substituted with 0. Then what I'll do, I'll convert this into numpy array np.array of encoded. So now I have my encoded text here. So Jack represent the number 2 represents the word Jack. Okay. Then what we'll do, we will predict by taking this as my input. So I'll call as y hat. So I'm sticking to the same representations here. Y hat is my prediction, right? So I'll just create a variable called as y hat. Y hat is equal to, so model dot predict. Okay. So predict classes. So I want it to predict classes. Then encoded dot, and this model takes 3-dimensional input, right? So I have to reshape it. I have to reshape this into a 3-dimensional array. So how can I do that? So reshape encoded dot shape of 0, comma 1, comma 1. So this is how I will encode it. That's it. So I will, object has no attribute okay. So again a spelling mistake here. It should be reshape. So now I have my y hat. So what it says, so it says some deprecated warning in future versions. This predict classes is not supported. So we'll have to make use of np.argmax. Okay, so we'll use this in my next model, that is 2 words in 1 word out model. Okay, so let's see that. Now let me check what this y hat is. So it's a 1. So it says 1, and we have to convert this back to my word, right? So for that, what I'll do, I'll run a loop for word comma index in tokenizer dot. We already know that it has word index, right? It's a dictionary. So word index dot items, it will give me key value pairs. So if index is equal to y hat, then print that word to me. Okay, so I inputted Jack, it gave me and. So why it is? So if we check our data, so Jack and Jill, right? But there is something called as Jack fell down, right? So it could have also outputted fell. Oh, I see here. So because of this, the accuracy is not getting improved, guys. So there are some caveats here in this data. So as it's a simple RNN, it will not remember what context we are actually asking it to, and also it's just 1 word in 1 word out, right? So what context would be getting binded with just 1 word, right? So that's why the accuracy is not getting increased further. So that explains the thing, right? So okay, so now what we'll do, we'll test it out with something else also. So what I'll do, I'll just copy everything in one block, so I'll not have to execute it again and again. So I'll say y hat and then I'll also have this word for loop here. So now I have Jack. So let's see what it predicts if I give the word fell as input text. Okay, so after fell, output is down. So it's doing fairly good job. So if I say went, so it says up. So it's good, right? So it's really doing good. But apart from some places where Jack is preceding fell and here Jack is preceding and, so it may fail at that particular steps. And also it may fail if we input Jill. It may or may not, it may output went or it may output came. It may output fell also. Let's see what it provides the output. So if I say Jill, so it is giving me went. So it's not giving me the output came, all right? So there are some limitations with this. Okay, so this is how our model is performing. It's doing fairly good, right? So it is actually learning the poem. It's just like teaching a kid to learn the poem, and it's now messing up with different inputs and it's producing some separate different outputs because it is not understanding which word the Jill is representing out of this particular sentence. So whether it's Jill after and or it's Jill before this and, okay, so it is getting confused. So it is just returning the first output after Jill, that is went. So this is how we can use this trained model to predict the next word by supplying the first word. Now, if you have seen my recurrent neural networks video on sequence modeling, there is something called a sequence generation which we can do. So this y hat here is a prediction, right? So it's actually a prediction of softmax. So it's a softmax layer, right? So our output is softmax layer. So we have 21 vocabulary. So it will predict the probability for each of those 21 words, right? So while sampling, what we can do, we can randomly choose those words, randomly choose one of those predicted words, not necessarily the actual class, and then feed that chosen word as an input to our next timestamp and then see what sequence it produces. So let's try to build that. So let me define a function called as sequence gen. So this is you can think this as a playing sort of thing with the trained model, okay? So let me just initialize with the input text as Jack, okay? So let's stick on to some 10 words. So I want this sequence generator function to generate a new text which is of length 10 words, okay? I have not used end of statement token here, so let's stick to the length of the sentence. So for I in range of 10, so it will start from 0 to 9. So we will have 10 tokens, 10 words. So I'll say encoded equal to tokenizer. So I need this here. I'll just copy this. Okay. Then I'll need predictions. I do not want predict classes. I want predict method. I want to use predict method, right? Why? Because out of these predictions, I will choose the random prediction. Okay. So I'll call it as predictions equal to model dot predict. So what I'll supply? I'll supply this encoded word, which is a which should be 3-dimensional input array. Okay. Now that I have this predictions in place. Okay, let's see how this predictions look like first. Break. Let me call sequence gen. So let me return predictions. I think it should be a 2-dimension array. Let's check sequence gen predictions is equal to. So if I check predictions, why it's not returning anything? Model dot predict predictions. So it should return me predictions, right? Return predictions. Let me just print it here. Print predictions. So sequence jump. Okay, so this is a two-dimensional array, but I want it to be a one-dimensional array. Why? You will see it in a while. So what I'll do, I'll remove this print, I'll remove this break. I will just take this as a 1D array. Now that I have the predictions, I can use np.random.choice in order to pick one thing, right? So what I'll do, I will say random choice is equal to np.random.choice. What it is? Predictions. And remember, this is of length 22, but we have vocabulary 21, and you know that first word is all, the zeroth index is already reserved. It will not be assigned to any word. So in order to avoid our random.choice picking the first output, what I'll do, I will just read it from excluding this particular number here. So I'll read everything here from here, and I'll choose some random number from this set, excluding this set. Hope this is clear, right? So I have done that. Now what I'll say, I will take this as my output. Y hat is equal to list of, so what it is, I need predictions from 1 till the end dot index of this random choice. I want the number right in the end. So these are all the softmax probabilities across 21 vocabulary. So I have chosen one of the softmax probability, and that I want the index so that I can convert that index back to my word. So that's what I am doing here. List of predictions dot index of that particular random choice. So now I'll have my y hat. Then I can use this for loop to map it to the word using that particular dictionary, right? So now I have my index in y hat. So what I can say, for word comma index in tokenizer dot word index dot items. What I'll say, if it's the same thing, index is equal to y hat, I'll say print that particular word, and this word will be my input to my, as this word will be taken as an input to my second time step, right? So what I'll say int text is equal to that particular word. Okay, now hope this works. Let's see. Okay, fine, it worked. So now you'll see some jumbled up sentence here, because initially Jack was the input, came is the output, then came is fed as input, right? Whatever predicted, that will be input in the second time step, and it predicted A as the output, and then A will be fed as input, then the is the output. So it goes on like this. It generates some random stuff, right? So this is how it works. Let me explain that to you. So I have one input at time step 1. I have this output y hat 1. In the second time step, this will be taken as input. So x2 will be y hat 1, and it will be y hat 2. And for the third time step, this will be the input. X3 will be equal to y hat 2. I'll have my y hat 3. So it goes on and on up to we have predicted y hat 10. Okay, so input will be y hat 9 here, and this will be x10. So this is how we can do a sequence sampling from a trained model. Sequence sampling from trained model. Okay, so hope this is clear. I'll end this video here. If I go on implementing the another architecture, that is 2 word in 1 word out, it will be a long video. You will lose interest. You might have lost the interest midway itself while I was changing the architecture, but that's how the training goes. how you decide on the architecture and all, right? So those are all hyperparameter tunings. So that's it for this video, guys. If you learned something from this video, please give it a thumbs up. If you aren't subscribed to my channel, please do subscribe. And if you are liking the content, please share it across your peers so that they will also be benefited from this. Okay. So till we see in the next video, in my next video, I'll implement a model which will be taking 2 words as input and providing 1 word as output. Okay. So this is 1 word in, 1 word out. In my next video, I'll implement 2 word in, 1 word out model. Okay. So till we see in the next video, happy learning. Bye bye.